Okay, so let's say you're dividing a polynomial by a binomial and you have a negative coefficient. No coefficient, if there isn't any negative sign, okay, we could use synthetic division. But if we're working with a negative coefficient, we have a number here, long division is necessary. So negative 5x minus 9. And another key piece here is you want to order these exponents from highest degree. Negative 5x to the third minus 4x squared plus 159x plus 270. If you don't feel comfortable with the negative sign, you can change the signs. You would have to change the sign of everything. You could make this plus, plus, all the way through. But you could also handle this just, regular with the signs. If you feel more comfortable, change the signs. Now, what I want to do is find something that I can multiply 5x by to get an identical result here, so that when I subtract it, they'll cancel each other out. So what I want to say is, okay, what times negative 5x? What times negative 5x is going to give me a negative 5x to the third? So in this case, I'm going to use an x squared, because the x2 and the x1 will give me an exponent of x3, and the negative 5 I already have. So we have a negative 5x to the third. Now don't forget, I also have to distribute this x squared to the negative 9, in which I'll get a negative 9x squared. So basically, you're getting this result by doing x squared times a 5x minus 9 and distributing here. Okay, you're distributing. And then don't forget, when you're dividing and you're doing long division, you're subtracting this from what's here. You're subtracting this. So actually, this is going to change our signs. And we'll see, these will cancel out, and you'll be left with a 5x squared, which is what we get from doing negative 4 plus 9. And then this will make its way down, 159x. Now again, I'm looking at this value, and our negative 5x outside here, and what times 5x squared? So negative 5x times what is going to give me a 5x squared. Now I want it to be positive, because I know once I add or subtract, the sign's going to change. So I'm actually going to do a negative x here, and because the negative and the negative will give me a positive 5x squared plus a 9x. Again, sign changes. This becomes a negative 5x, this becomes a negative 9x, and I'm left with 150x plus 270. And then if I'm looking at the negative 5x, what can I multiply by? I want it to be the same. I'm going to use a negative 30. Because a negative 30 times negative 5x is going to give me an identical result. Negative 30 times negative 9 actually gives me a negative result here, which leaves me with a zero remainder, which allows me to get basically a perfect factor, knowing that this x squared minus x minus 30 will be a factor. Don't forget, we started with a negative 5x minus 9 here. And if I wanted to find zeros, one thing I could do is, we like to say, unfoil this and get a negative 5x minus 9. Now I see my middle number here is negative, okay, and I'm looking at my factors for 30, 1 and 30, 2 and 15, and then the 5 and 6. I could use 3 and 10 as well, but I'm looking at the 5 and 6. I'm looking at the 5 and 6 because the difference between these two numbers is 1. The difference between these two numbers is 1. If you see my middle number here is really a negative 1x. And it's a negative, so I'm actually going to make the 6 negative and the 5 positive, because I know once I combine my outside and my inside, that's going to give me a positive 5x and a negative 6x, which is going to give me in turn that negative 1x I have in the middle. And then what I could do to solve for zeros is just simply set up the negative 5x minus 9 equal to 0, add the 9, negative 5x is equal to positive 9 divided by negative 5, x is equal to negative 9 over 5. And my two other results, I'll have x minus 6 equal to 0, and the x plus 5 is equal to 0. Solve for these, this will give me x is equal to 6 and negative 5. So altogether, my zeros are going to be 6, negative 5, and negative 9